Hello and welcome. This is going to be our step-by-step binder lesson for how to solve systems of equations by substitution. But we're going to see some harder type problems where things aren't set up as nicely for us to use the method of substitution, but we're going to show that it's still possible with these problems here. Go ahead, put your name up there. I'll be Key East today. I'm recording this on the 30th. And write whatever period you are. All right, so step one is look for the easiest variable to isolate. Look for the easiest variable to isolate. So what might make a variable very easy to isolate? It could be already isolated. So we're not going to assume that it's a hard type problem. Maybe you do already have a variable that's isolated. All right. It could have a coefficient of 1. If it has a coefficient of 1, it's pretty easy to isolate because you can just move everything away from it. Or everything is divisible by its coefficient. So maybe we don't have a coefficient of 1, but we can divide by its coefficient and we can avoid fractions that way. Sometimes you won't find a variable that meets any of these, and we'll just have to pick the smallest coefficient in that case. But if you can, look for one that's already isolated, one that already has a coefficient of 1, or one in which everything is divisible by its coefficient. All right, step 2 is isolate that variable. All right, and at this point, it becomes an easy type problem. So I'm just going to summarize our steps for solving. We want to substitute the expression for the variable in the other equation and we want to step 4 solve. I'm just going to really quickly summarize this. Step 5 substitute the value Step 6, solve again, or solve for the other variable. And step 7, double check with the equation you didn't use, and why not, step 8, write your answer as an ordered pair. Okay. So really, it's just a new step 1 for how to do systems of equations by substitution when it's harder, and that is we got to look for the easiest variable to isolate. It can either be already isolated, coefficient of 1, everything is divisible by that, its coefficient, and then we're going to isolate it. So in problem 1, we've got one of our actually easiest cases where we're actually told half of the answer. Y is equal to negative 3. So this y is already isolated, and there's no expression over here. It's just the value. So this can come in and replace this y up here. Now I can copy down that top equation, negative 2x minus 3 times negative 3 equals 9. And now just solve for x. Negative 2x plus 9, negative times negative is a positive, equals 9. Subtract 9 from both sides, negative 2x equals 0. Divide by negative 2, and I get x equals 0. All right, and then we'll put this together as an ordered pair, 0 comma negative 3. Just like that, and we're done. So that's one of our easiest cases. Next one's not going to be so easy, but this still isn't the most difficult case. We're looking for an easy variable to isolate. Well, this y right here already has a coefficient of 1. So that makes that y an easy one to isolate. So to isolate it, I need to move things away from it. So I'm going to add x to both sides. And since it's our bottom equation, we can just start our work right here. And I get the equation y equals x minus 4. All right, now this expression here, substitute the expression for the variable in the other equation, can come in and replace this y right here. Y is equal to x minus 4, therefore y can be replaced by x minus 4. Now I just got to copy down that top equation, but with the y substituted. So negative 8x plus 6 times, in parentheses, x minus 4. When I substitute, I use parentheses, equals negative 22. And now the only variable here is x, so it can be solved for. Let's distribute that 6. We'll get negative 8x plus 6x minus 24 equals negative 22. Combine like terms, I'm going to also add 24 to both sides in this step. And those combine to be a negative 2x equals 2. Divide by negative 2. Get x equals negative 1. That's only part of my answer. But when I go to plug it back in, you can plug it in wherever, but use your simplified equation. That's going to be the easiest spot. If I plug in right here, then this is already solving for y, so there's not going to be any rearrangement. Okay, I'm going to finish this and then I'm going to write that what I just did. So y equals negative 1 minus 4, y equals negative 5. So I've got an x and a y value, plug them in, negative 1 comma negative 5 into an ordered pair. And I've got my answer for number 2. And we use the second equation, so let's use the top equation to double check. 8 minus 30 equals negative 22, negative 22 equals negative 22. It's double checked. All right, so in step 5 here, when we substituted that value, we can use the equation from step 2 to make our lives a little bit easier. That's always going to be the easiest place to plug it in. All right, let's try number 3 here. I have to be really efficient with my space. All right, there's your system. I look, are any of my variables already isolated? No. Do any have a coefficient of 1? No. If I divide by the coefficient of any, will it go into the other coefficients evenly? Yes. And the easiest one to target is this 4x right here. All right, because all of the coefficients in that top equation are divisible by 4. So if I write that equation off to the side here, my smallest pen possible, 4x plus 8y equals 24, and I divide every single term by 4, I'm not going to have any fractions. If you do end up with fractions, it's okay, it's going to work out, but here I can avoid them. X plus 2y equals 6. And now I can isolate that x by just moving this 2y away from it. Minus 2y minus 2y. I get that x equals 6 minus 2y. All right, box around this side. This goes and replaces the x. Now, you can sometimes make a mistake here if you go plug it back into itself. We used the top equation to isolate x, so it has to get plugged into the bottom equation. We have to use both equations. If we're only using one equation, then it's always gonna look like we have infinite solutions, but we don't here. We only have one solution. All right, so that x there is gonna be replaced. Negative 6 times 6 minus 2y minus 7y equals negative 11. Go ahead, distribute. Negative 36 plus 12y. Careful with positive negatives there. Minus 7y equals negative 11. Go ahead, add 36 to both sides and combine my like terms in one step. And I get, that's going to become a 5y equals negative 11 plus 36 is 25. Divide both sides by 5. Get y equals 5. All right, and then where's the easiest place to plug that back in? It's right over here in our manufactured equation, because that's already got x isolated. So now we've just got 6, well, I should start with my x equals 6 minus 2y, but y is going to be replaced with a 5 here. So 6 minus 2 times 5. X equals 6 minus 10. X equals negative 4. And then we write it as an ordered pair. Negative 4 comma 5. All right, and we used the second equation to solve, so let's plug these both back into that top equation. Actually, we used the top equation to solve, so we'll plug it into the second equation to double check. Let's see, that becomes a 24 minus 35 equals negative 11. 24 minus 35 equals negative 11. Negative 11 equals negative 11. It checks out. Okay. Number 4. Man, this one would be very easy with elimination because I see I already have a 0 pair. But let's say we wanted to force the issue and do this with substitution. We still can. What variable would be the easiest to isolate? Well, actually this x, this y, and this y here are all pretty easy to isolate. I'm actually going to go for the top equation because I see that with this matching coefficient, I'm going to be able to get pretty small numbers. That's going to help me out. Okay, need some extra space. So I'm going to go down here with that top equation. All right, and I'm going to isolate, I'll say x. Everything is divisible by this 8, so this is going to be pretty easy. Divide everything by negative 8. And I get x plus y equals negative 2. Now I can isolate the x by just subtracting y from both sides. X equals negative y minus 2. And then that goes in and replaces this x here. So what's that going to look like? 8 times negative y minus 2 plus 4y equals negative 4. Negative 8y minus 16 plus 4y equals negative 4 after I distribute. Let me add 16 to both sides, and then at the same step, combine my like terms. And these come together to become a negative 4y equals 12. Divide by negative 4, divide by negative 4. And I get y equals negative 3. Got to plug that negative 3 back in somewhere. This is a really good spot to plug it in. So x equals negative 3 minus 2. X equals 3 minus 2. X equals 1. Now just write it as an ordered pair. 1 comma negative 3. And we used the the top equation to solve, so we'll use the bottom equation to double check. 8 minus 12 equals -4, -4 equals -4. That checks out. All right, one more here. Well, this x is already isolated, so that will be the one that we use for substitution. I subtract 6y from both sides. X equals -6y plus 2. This here gets plugged in for x in the top equation. We use the bottom equation to create it, so we're going to plug it into the top equation. And we get 2 times x, but that becomes 2 times in parentheses -6y plus 2 plus 12y equals 5. Distribute the 2 here. And we get -12y plus 4 plus 12y equals 5. These are going to cancel out. -12y and positive 12y, and we just get 4 equals 5. This is a false statement. 4 does not equal 5. So if we achieve a false statement by normal algebraic steps, it means that our original system had no solution. All right, and if we want to make a note at the bottom of our page for that, something like 1 equals 1 is true, and that means infinite solutions. If I get something like 0 equals 1, that's false, and that means no solutions. Okay, that's that for this video. There's a couple more problems on the back of this worksheet for you to try with the substitution method that are a little bit more difficult, and I'll post their answers in the description. All right, have a great